Today we are reviewing Gravity Platformer 100% Pen by a Japanese scratcher, Mizyumaru. Everything is drawn with the pen module, and you interact with the project with the arrow keys, up arrow to jump, and you click to generate more stars or circles. It looks like once a circle is stuck to the center, none of the others are pulled in as strongly. But if another circle gets stuck to the center, then that becomes the pivoting point. Probably the most interesting about this project is that it is all pen drawings and none of these are sprites. Looking at the code now, you can see that everything is managed with list and regular variables, and it is operated on the pen module. And so in today's review, it's going to be a twofer. You get to learn some Japanese at the same time as looking at some code. There's a bunch of custom modules to organize the code. One for the background, heike, one to create, tsukuru. If the create equals 0, there's two modules that initiate for movement and self-movement, and finally a writing module. The module for the background is very simple, but a nice way to make a background once the program is initiated. It makes a big pen colored black. It goes to the top left corner, puts down the pen, moves to the top right corner. After that, it moves down to the bottom right corner, and finally moves over to the left bottom corner and moves the pen up. Next up, we have the create module that's looking if the player is clicking. And so if the player is clicking and this create equals 0, it's going to do this custom module called tashikame, which means to check. And if the check returns a minus, it'll add the current mouse X and Y position plus the X and Y variables, which were initialized to 0 and 200 respectively, to the list for X and Y locations. The purpose of having a list for X and Y is because there are going to be multiple stars that are being drawn and they need to be tracked. It's also going to add this attribute of okisa or size to the list, and it's always going to be 60, it appears. Then create is updated to have the number of things in the list. Then if the check is greater than 0, it's going to delete that item from each of the lists, and the create will be reset to a minus. So far, this create module manages adding and removing things from lists. So if the mouse isn't clicked, it's going to look to see if there's things in the create variable, meaning if it's greater than 0. And what it's going to do with this is it's going to look at something called tashikame kyori, the check distance, if that is greater than the item of create of the size divided by 2. So this is essentially going to be 30 because all of the stars are size of 60. So if it passes this check, it'll replace the item create in the list of sizes with another size. And otherwise it resets the create variables to minus or 0. Next, let's look at the check module, which has 3 variables initialized. The check is set to minus, A is set to 0, I think it's a counter, and then the distance check is set to a huge number. Next up, we have iteration through a list for all of the items in the X list, meaning all of the stars that were generated. For each item in the list, it will go to the X and Y location of that item, set the distance to some complicated math. It updates the distance according to the square root of all of the X information squared plus all of the Y information squared. Then, if that distance minus the size divided by 2 plus 20 is less than the check distance, then the check distance will be updated. So if this modified size is greater than the distance, it's going to set the check to 0. Finally, if there's multiple things on the list, it'll set the check to the counter. Next, in the self-movement module, there's an equation for pointing in the direction of arctangent of something that I don't understand. Let's go to Khan Academy for help with arctangent.
It is even asking us the tangent of theta. This is just a straight up vanilla non-inverse function tangent. That's equal to the sine of theta over the cosine of theta. And the sine of theta is the y value on the unit function, on the unit circle. And the cosine of theta is the x value. And so if you draw a line, let me draw a little unit circle here. So if I have a unit circle like that, and let's say I'm at some angle, let's say that's my angle theta, and this is my y, my coordinate, it's x, y. We know already that the y value, this is the sine of theta. Let me scroll over here. Sine of theta. And we already know that this x value is the cosine of theta. So what's the tangent going to be? It's going to be this distance. It's going to be this distance divided by this distance. Or from your Algebra 1, this might ring a bell because we're starting at the origin from the point 0, 0. This is our change in y over our change in x. Or it's our rise over run. Or you can kind of view the tangent of theta, or it really is, as the slope of this line. The slope. So you could write slope is equal to the tangent of theta. So let's just bear that in mind when we go to
a lot of boring math later.
So basically it takes a bunch of numbers and gives me a new direction. Cool. Okay, so we have in the beginning a check for touchability and what to do if the arrow keys are pressed. After the direction is chosen by the equation, then the x plus and y plus are updated by the sine and cosine of direction. And since I don't want to put you guys through another math video, I'm going to make a module to test out how these variables affect each other. To summarize the results of this experiment, when the direction is 0, the y is 1, and when the direction is 90, the x is 1. I think the only problem I have now is that I know what it does, but I don't know what its significance is, except that it's a modifier. And on the bottom, you have the jump mechanic. So after the keys are sorted out, the movement module repeats through the list for however many stars are in play. The direction, the distance, and x and y variables are all updated. And fun fact, if you can't read this, you can open up Google Translate on your phone and point the camera at the screen and it will translate for you. So after reinitializing all of the variables for the items in the stars, the counter is reset to 0. Then we go and set the distance again. We check the distance against the size. And then we repeat it 10 times to check the distance against the size and set up the direction, x and y, and distance again. From my Scratch experience, users will usually repeat something a lot if they want it to be smoother in terms of movement. And finally, after all of the variables are set, reset, checked, and rechecked, the pen module can go ahead and get on with the drawing. So first it draws that white circle in the center of the screen, and then it draws all of the stars that it knows how to draw, including the ones that you add later. I think if you were going to remix this project, it would be interesting if you could find a way to randomize the size of the stars that are generated. And that brings us to the end of our review. We looked at Japanese Scratchers code, we translated things for all of you English-speaking Scratchers, and thanks for watching. Subscribe for more reviews, and leave a comment if you'd like your own project reviewed.